Hello everyone, my name is Praful Kumar, and today in this video I'm going to show you how you can use Cyber Workbench tool, and then how you can synthesize a C code to RTL. So today we'll be creating a moving average circuit. So this basically is taking 8 inputs and it's calculating the running moving average of the last 8 inputs you give. So for instance, if you give 8 in the first one, so it's gonna be 8 by 8, that's gonna be 1. So again, if you give 8, it's gonna add up the 8 plus 8 by 2, that's gonna be 16 by 2, 16 by 8. So it's gonna be it's gonna give us two output. So this is the okay, so this is the C code that we have. So I have created an array which stores the last 8 inputs. So I've created input 0 also. This is gonna take each of them and then it's gonna store into the array. So this is the boolean toggle. So this is nothing but the push button. So I have created an integer called moving average sum and I. So in this, if you see, this is the mapped segment, this is gonna go to the display 7 segment display. So if you can see, when my push button is active, so that is when it is 0. When it is pressed, so it's gonna enter the loop, and then I've created a for loop from 0, that is decrementing up to from 7 to 0, decrementing to 0, and I'm storing each and every input into the array. And then if you see here, I'm gonna adding up all the numbers stored in the array here from 1 to less than 8. So once that is done, once I add up the last 8 inputs, I'm gonna assign that to moving average. So this is nothing but sum by 8. So let's assume if the sum is 8, it's gonna be 8 by 8, that is 1. So moving average is 1. So once the moving average is 1, it's gonna shift to case 1. So if you can see, in case 1, uh, I have mapped it to 1. So this will convert to 1 in 7 segment display, the case 1. So subsequently I have case 0, this gonna display 0, it's gonna display 1 2 3 4, like that. I've created 32 cases for this. So once the selection has been done, so I'm gonna map it to true display, and then the display uh, and then the display variable, it's gonna go to the 7 segment to display. So I'm going to right click on this code here, click on analyze. So build has been started, and then build has been end here. So I'm going to right click on this, click on here, go to synthesize, generate RTL. Okay, so the build has been successful here, if you can see. So here, if you can see, this is the RTL code generated by Cyber Workbench. So okay, so if you can see, it has created a clock and reset for the design. So this is the RTL code. What I'm gonna do is I'm gonna copy this code, and then I will paste that into Intel Cortex Prime Lite. So if you can see, I've already created a project in here. I'm gonna go to file. So if you can see, this is the code which Cyber Workbench has generated. So I've pasted the code here. So this is the synopsis design constraint file here. So since I've already compiled the file, what I'm gonna do is I'm gonna program my FPGA board. I'm gonna double click on program device. Okay, I've selected the file here, go to change file, and then output files, and select the SOA file here, and then click on start. So now I'm going to show you the output into the FPGA board. Okay, so if you can see, I'm using the 7 switches here. So that is from 0 to 7 here. So these are my inputs, these are going to be my inputs, and this is my push button that I'm using to take the input, and this is the reset button I'm using to reset the circuit. So now what I'm gonna do is I'm gonna pass in number 8. So I'm gonna make this 1, and then I'm gonna push button, so it's gonna be 8 by 8, that's gonna be 1. Okay, so now I'm gonna give the second input, so it's gonna be 8 plus 8 by 2, 8 by 8 plus 8 by 8, and then it's gonna be 2 here. 16 by 8 is nothing but 2. So again it's gonna be 16 plus 8 by 2, so it's gonna be 3, if you can see here. So even if I give multiple inputs, I'm gonna reset it. and then let's say if I give 4, and then if you try, so it's gonna be 4 by 8, it's gonna be 0. Again if you press, it's gonna be 1, that is 4 plus 4 by 8, it's gonna be 8 by 8, that is 1. And then again if I give, it's gonna be 12 by 8, it's gonna be 1. Again if I click, it's gonna be 2 here. If you see, yeah, that is nothing but 16 by 8, it's gonna be 2. So this proves the working of the circuit. Thank you.